Hello everyone! Today we're going to dive into a topic that I know can look a bit scary at first. Inverse trigonometric functions. But don't worry, my promise to you is that by the end of this, you'll find the basic ideas are actually much simpler than they look. So let's get right into it.
Alright, let's kick things off with a simple question. Look here, if sine of x is equal to 1 by 2, what is x? Now I bet the first thing that popped into your head was pi by 6, right? 30 degrees. And you know what? You're absolutely correct. But, and this is a big but, that's not the complete picture. And that, my friends, is the trap.
So take a look. We know sin of pi by 6 is 1 by 2. But wait a minute, what about sin of 5 pi by 6? That's also 1 by 2. And it doesn't stop there. There are actually infinite angles that give us the same sine value of 1 by 2. This is a huge problem, isn't it? If we want to go backwards, from the value back to the angle, which one do we pick? We can't have 100 different answers. We need one single official answer.
Think about it like this. It's like having an Instagram feature that's supposed to find a person's username just from their profile picture. Now, what happens if thousands of people are using the exact same, let's say, picture of a cute cat as their DP? The feature would be totally useless, right? It can't give you one unique username. It's the exact same problem here. We need a system to get one and only one unique angle from a value like 1 by 2.
So how do we solve this? Well, what does Instagram do when there are many fan accounts for a celebrity? They give a blue tick to the one official account, right? Mathematicians did something very similar. They basically created an official account rule. They decided to pick one specific range of angles and said, okay, from now on, the correct answer will only come from this special range.
And this official range has a special name. It's called the principal value branch. Honestly, just think of it as a VIP section at a concert. There are thousands of seats, but the VIP section is a special, restricted area. By agreeing that our answers must come from this VIP section of angles, we guarantee that for every value, we get exactly one unique angle back. It makes the whole system work perfectly.
Okay, so now that we have this official account rule in place, it's time to meet the stars of the show. The 6 inverse trigonometric functions. Each one of them, sine inverse, cosine inverse, and all the rest, has its own unique principal value branch.
Now, pay very close attention. This table right here, this is your key to the entire chapter. Seriously. I would say pause right now and take a screenshot, because you're going to refer to this again and again. It shows us two crucial things for each function. The domain, which is basically the set of allowed inputs, what numbers you can put in, and the range, which is that VIP section we talked about, the principal value. This is where your answers must come from.
So let me say it one more time, because this is where most students make mistakes. Your final answer for any, and I mean any, inverse trig problem absolutely must fall inside the range column from that table. If your answer is outside that range, it's wrong. Simple as that. So for example, when we find sine inverse of 1 by 2, the answer has to be in the range minus pi by 2 to pi by 2. So always check this table first.
All right, let's move on to a type of question that you will definitely see in your exams. At first glance, it looks really complicated, but I'm going to show you a super simple visual hack to solve it in just a few steps. I call it the right triangle trick. So what about something like this? Sine of cosine inverse of 3 by 5. Phew! A function inside another function. It looks pretty intimidating, right? But trust me, with our new triangle trick, this is going to be surprisingly easy.
Okay, step 1 is super simple. Whenever you see a messy inside part like this, just give it a name. Let's call the entire inside part cos inverse of 3 by 5 theta. So all this means is that theta is some angle, and the cosine of that angle is 3 by 5. Step 2, rewrite and draw. Since we said theta is equal to cos inverse of 3 by 5, we can just rewrite this as cos of theta equals 3 by 5. Now what do we know about cosine from class 10? It's adjacent over hypotenuse, right? So let's just draw a simple right-angled triangle where the adjacent side is 3 and the hypotenuse is 5. All right, step 3, find the missing side. This is easy, we just use Pythagoras' theorem. You probably already know this one. It's a 3, 4, 5 triplet. So the missing opposite side has to be 4. And there we go, our triangle is now complete. And now for the final step, let's go back to our original question. It was sine of cos inverse of 3 by 5. But remember, in step 1, we replaced that whole messy inside part with the simple name theta. So the complicated question has just become, what is sine of theta? See? So much simpler.
And to find sine of theta, all we have to do is look at the triangle we drew. Sine is opposite over hypotenuse, which, from our triangle, is just 4 over 5. And that's it. That's the final answer. See how that scary-looking problem just melted away with a simple triangle?
Okay, just one last thing. Let's quickly see how all these rules we've talked about, especially that master table, actually create the graphs of these functions. It's really cool to see the connection.
So let's take a look at the graph of y equals sine inverse of x. Notice how the graph is totally stuck horizontally? It doesn't go any further left than -1, and it doesn't go any further right than +1. Why is that? Well, just look back at our table. The domain, the allowed inputs for sine inverse, is locked between -1 and 1.
And what about the height? Look at the y-axis. The graph never goes higher than pi by 2 and never goes lower than minus pi by 2. And again, this is not a coincidence. This is because our official answers, the range for sine inverse, is locked between those exact two values.
So the main takeaway here is this. The rules from that table are not just some random numbers to memorize. They literally create the shape of the graph. The domain tells you how wide the graph can be, and the range, or our principal value branch, tells you how tall it can be.
Phew! Okay, we've covered quite a bit. So let's do a super quick recap of the most important things you need to remember.
First, the whole reason we have principal values is to make sure we get just one unique answer. Second, that domain and range table is your absolute best friend for this chapter. Screenshot it, memorize it. And third, don't forget the right triangle trick. It's a lifesaver for those complicated-looking problems.
Honestly, you're doing great. If these 3 big ideas, why we need principal values, how to use the table, and the triangle trick, make sense to you, then you have a really solid foundation to handle anything else in this chapter.
So, I'll leave you with a final thought to chew on. We now know that an inverse function gives us a single specific angle. But what do you think happens when you need to add 2 of these inverse functions together? That's where we get into the properties of these functions, and that's exactly what we'll explore in our next session. See you then.